Alrighty, so here we have a function f of x, and we don't know what f of x is, right? But we see the graph, so that's nice. And it has zeros at x equals -1. I see that here. I can mark that up a little bit with a little dot. X equals 2, which is over here, and then x equals 4. What is the most likely the multiplicity of the 0 x equal 2? Now, multiplicity, oh dear, that's not a nice little underline. Let me clear that. Multiplicity, what this term means is just how many times might that 0 be there. So, for example, we have f of x, and we're looking at x equals 2. So, that means that we have a 0 that is x minus 2 to the power of something. I'm going to call it n. We don't know what n is. Now, we learned that if we have a function, any graph, and it goes straight through, like that, if it goes straight through, it doesn't jump up and down, then this one has an odd multiplicity. Sorry that it's sideways. I don't know why. This one has an odd multiplicity. So that means that, let's say if this was 2, then we would have x minus 2 to the power of 1, or x minus 2 to the power of 3. But here, that's not what's happening, right? Here we see, oh, it goes up to 2, it hits it, and then it bounces back down. It doesn't go straight through. When you have a situation where the function might come to something and then come back up, bounce up like we see here in the problem, or like here, this means that the function has an even multiplicity. Even multiplicity. It means that it happens multiple times, but it needs to happen an even number of times. So that means we get x minus 2 to the power of any even number. So it could be 2, or x minus 2 to the power of 4. In this case, the question it gave us options of multiplicity m equals 1, m equals 2, or m equals 3. Here, since it does not go straight through, it bounces up and down. We know it has an even multiplicity. And the only one of these options that's even is 2. And so this function has a multiplicity of